Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 9-2 lesson on intuitive limits of the infinite variety. In this one, we will be finding infinite limits using a graph. For your warm-up, see if you can find the following limits for this graph. And if you notice on these limits, we've got some infinities. We've got, as we approach, 4 from the left and the right, so there's some crazy stuff going on here. Just answer it to the best of your ability, and we'll talk about it over the course of this lesson. So let's talk a little bit about infinity. If the x or y values for a function are increasing or decreasing without bound, in other words, forever, we can use infinity to describe their behavior. And there's two kinds of infinity. Positive infinity, or just the infinity with no sign on it, we can say increasing without bound. And if it's a negative infinity, that's decreasing without bound. It's important to note, though, that if we say a limit equals infinity, what we are really saying when we say that is that it is unlimited in a certain direction. I mean, negative and positive infinity are not the same direction, but they're just directions. They're not actually constant numbers. Let's talk about some limits to infinity. So you can approach infinity and negative infinity from the left and the right side if you have a vertical asymptote. And there's two cases for this. One is convergence. That's when a function is approaching the same infinity from both sides. For example, down here, as we approach a from the left, we're approaching negative infinity. As we approach a from the right side here, we're approaching negative infinity. So if you have the same infinity for both sides, you can write that infinity for the two-sided limit. And we at least understand that this thing is approaching infinity, negative infinity, from both sides. Now, there's another case, divergence, which is this other graph right here, and that's when you're approaching different infinities from each side. So for example, here, the left side limit, we're approaching negative infinity. From the right side, we're approaching positive infinity. So this one, we can't really say anything about the two-sided limit. Since you're not even going the same direction, we would say this one has no limit at all. So at this point, there's an interesting question that pops up, and that is, do infinite limits actually exist or not? I mean, we had the diverging ones where we just wrote dne, so those definitely don't exist. But what if you have a converging infinite limit? So on the one hand, the official definition of limits talks about finite values that we're approaching. So infinity would be off limits then. You can't really talk about the limit of a function if it's unlimited. At the same time, those converging asymptote branches are approaching each other, and they seem to pass that intuitive converging pencil test. They're at least going toward the same x value in the same direction. The AP curriculum says that infinite limits don't exist. That's the official word here. If you're asked if an infinite limit exists, the answer is no, according to the AP graders. Having said that, we still write positive or negative infinity instead of dne for the converging infinite limits. You could just think of this as dne with direction. It's a little bit better than just writing dne and throwing up our arms, but it still doesn't technically exist as a limit. Let's take a look now at limits at infinity. One case is when you have a horizontal asymptote. So if you have a horizontal asymptote, your limit at negative or positive infinity as you go to the far left or the far right is going to be a specific number. For example, here, the limit as x approaches negative infinity as we go as far left as we can, that's going to be the y value 3. And the limit as you approach positive infinity, go to the right as far as you can, that will also be positive 3. However, it is worth noting that you can have different left and right horizontal asymptotes. If we just flip really quick back to our original warm-up problem, going to the left we have a horizontal asymptote on the x-axis, but to the right we have another horizontal asymptote at y equals -1. So, although this graph that we just looked at has one horizontal asymptote for everything, we can't assume it's the same on the left and the right without double-checking it. Another case is when you have an unbounded function, like this cubic function here. In that case, you're going to have infinite limits as you approach left and right infinity. So for example, as x approaches negative infinity, y is approaching positive infinity. So we could say the limit at negative infinity is positive infinity for this graph. And as x approaches positive infinity, well, now your y values are approaching negative infinity. And again, these aren't really limits, they're just kind of dne with direction. They're telling us a little bit about the behavior of the graph. Here's another interesting case, an oscillating function. This is just sine, and we're bouncing up and down forever. It's definitely centered on the x-axis, so does this have a limit as you go to the left or the right? It turns out if you have a function that bounces back and forth without getting closer to a specific y value, that will not have a limit. The left limit and the right limit are both dne for this one. Having said that, if you had a function that at least on one side was oscillating but kept getting closer and closer and closer to the x-axis, then you could say that it had a limit. Now that we've got a little bit of experience with infinity under our belt, go back to your warm-up problem and try it again and see if you got the right answers. All right, let's see if we agree on this. So as x approaches negative infinity, that's as our function moves to the far left, we have a horizontal asymptote that appears to be on the x-axis. They usually don't draw them on the x-axis, they're kind of hidden. So that would be a y value of 0 that we're approaching. As we move to the far right, as x approaches positive infinity, now we have a horizontal asymptote at -1 that we're approaching over there. As x approaches 4 from the left side, we're going up forever, so that is positive infinity, you could call that. And then as we approach 4 from the right side, also going up forever, so approaching infinity. Now how about the two-sided limit? Well, we said if the infinities agree, you are allowed to call it whatever infinity that you agreed on, so we could also call that positive infinity. But now to the question of, does the limit as x approaches 4 actually exist? Just because we're able to write something here doesn't mean it actually exists. Remember, infinity is really just dne with direction. So thus far, we've been doing everything with graphs that we can just look at. At some point, though, we're going to look at the algebraic side of it. So for your wrap-up, see if you can figure out at least 3 function families that have either infinite limits at an x value, in other words, vertical asymptotes, or finite limits at infinity, either horizontal asymptotes to the left or the right. All right, let's see if we came up with a similar list. One big example is the exponential functions have that horizontal asymptote, and logarithmic functions have a vertical asymptote. There's another one that's related to these two that we haven't really gone over called logistic functions. These kind of have a weird format. They've got some exponentials in them, but in the denominator of a fraction. These have horizontal asymptotes, 2 horizontal asymptotes, one to the right, one to the left. Rational functions have vertical and horizontal asymptotes. And then these trig functions like tan and cotan, and also secant and cosecant, those all have vertical asymptotes. So these are all functions that when you see them, you want to be thinking about these asymptotes as you find different limits. So that's all for now. Until next time, this is Mr. Sutton, signing off.